Alright, I'm still going, and I'm doing these one after another, and you can probably tell I'm getting tired. Alright, so what are we doing now? Whoops. Z, Control Z, makes that go away. And I'm going to need to draw some axes, and let me get my black color here. So we're going to do the volume of a solid obtained by rotating a region around the x-axis. So what does the region look like, first of all? Uh, you know, I think I might be able to show you, because I already kind of did it. Is this the same one? So if this is the same one, let me go back and make sure. Okay, so I've got y. Okay, so what are the curves? Y equals 0. What is that? That's just the x-axis, right? This is the x-axis. Oh, Jesus, Louise. Okay, so this is the x-axis, and y equals x to the fourth is it basically just looks like x squared. It's a little more flat around the origin, and x equals 0, so that's just the y-axis. And we have the line x equals 1, which I will represent with the most disgusting color in the entire color palette. And so this gives the region. Okay, why is that? It's because it's enclosed on the bottom by the x-axis, on the left by the y-axis, and on top by this curve. And so this is the region. Okay. All right, and so now we're spinning this around, and that's giving us this three-dimensional kind of thing. Okay, and actually it's not quite what I have drawn in Maple. I did this when I was working on something else, but we could do something in Maple. Should I do it? I'm doing it. And okay, so volume of revolution. So what's the curve that we're interested in? It's basically x to the fourth, and we're going from a equals 0 to b equals 1. So show me this one. And this is what it looks like. It looks hollow, but it's really solid. And yeah, okay, so actually this thing is just cutting right to the chase here. We can see that the answer should be pi over 9, so let's make sure we get that. So close this, and let's go back here. All right, and so let's set up the integral we want. So we need to know what a cross-section of this thing looks like. So remember how volume works. So the way volume works is you need this function called the area of a slice function. So when you make a slice at x and then take it out and kind of spin it around, then you get a cross-section with x in the center. Wow, it should have made a better circle than that. No, I can't make a circle that's good enough for it to even recognize. There we go. Okay, so here's x, all right, and it's a cross-section of the horn here. And so you can see that the radius is just going to be the function with x plugged in. And so people just stare blankly at me in class sometimes when I say this, and it frustrates me as much as it frustrates you, because the radius of this thing is just given by the curve, so of course it's x to the fourth, so stop arguing with me. So it's x to the fourth power. Okay. All right, and so what is the area of this kind of abstract little circle? It's just pi r squared. The radius, as you can see, is x to the fourth. So it's pi x to the fourth squared. Okay, this is the area of a slice. And this, of course, is the same thing as pi times x to the 8. So what we want to do is integrate the area of a slice function over the limits. So remember we decided this is 1, and of course the origin is 0. So we just integrate the area of a slice from 0 to 1. And it's this. So from 0 to 1, pi x to the 8 over dx. And those of you who are really smart and remember the answer from Maple can see that we're right. So this becomes pi times x to the 9th over 9. And the limits are from 0 to 1. Okay, and now do the plugging in thing. When you plug in 0, it dies, so we just have to plug in 1 And when you plug in 1, x to the 9, da, da, da. So the answer is just pi over 9. Okay, great. So this one is done, actually. This is kind of relatively easy, huh? Yes, it is.